The north pole of one magnet attracts the south pole of a second magnet, while the north pole of one magnet repels the other magnet's north pole. A magnet creates an invisible area of magnetism all around it called a magnetic field. A common saying is, like poles repel and unlike poles attract. Magnets can either attract or repel each other. A permanent magnet is an object that produces a magnetic field around itself. This field enables them to stick to each other and to some types of metals. If the north pole of one magnet meets the south pole of another, the two will be attracted. But if either both north or south poles meet, the magnets will repel one another. When electric current runs through a wire, it generates a magnetic field around it. The coil concentrates the magnetic field by producing a stronger current. The strength of an electromagnet can easily be changed by changing the amount of electric current that flows through it. The poles of an electromagnet can even be reversed by reversing the flow of electricity. An electromagnet works because an electric current produces a magnetic field. The parts that make up a basic motor consist of a ventilation opening, end bell, bearing, housing, field poles, shaft, cooling fan, slots, core, commutator, bearing, terminal box, and the end bell. In a basic motor, the coil rotates north and south, which creates a magnetic field. The brushes carry the current to the commutator, and the commutator then reverses the current. A wire with an electric current produces a magnetic field in its surroundings. The strength of the magnetic field depends on the intensity of the current and the shape of the wire. Each wire with a current flow is practically an electromagnet. In permanent magnets, the fields are also created through currents, but these currents are not macroscopic currents in which charged particles flow in one direction. They are microscopic electric currents, which, in the case of ferromagnetism, are created through certain electrons rotating around themselves in the material. An electron spin can be viewed as a microscopic small circulating current. The motor is connected to a battery. When the switch is closed, the current starts to flow and the coil becomes an electromagnet. In this case, the current is flowing anti-clockwise in the top of the coil. This makes the top a north pole. This north pole is attracted to the south pole on the left, so the top of the coil turns towards the left. Once the coil gets to the upright position, there is no turning force on it because the electromagnet of the coil is lined up with the permanent magnets. If the current in the coil were constant, the coil would stop in this position. However, to keep it spinning, the commutator breaks contact in this position, so the current stops for an instant. The momentum of the coil keeps it going and the contacts are reconnected. However, they are now the other way around, so the side of the coil that used to be a south pole is now a north pole.